doing lab 5, boards and lights. We'll be using this electrical circuit board. The objective of this lab is to investigate the behavior of bulb lights in a circuit and different types of circuit. We'll be more familiar and using circuits and designing circuits, and also we'll be able to draw a circuit diagram. So we'll be using these 3 bulbs. They are identical, so they should shine with the same brightness. In the first part, we will design a simple circuit with 1 bulb. Instead of using D-cell batteries, we'll be using the power supply. And as you know, the power supply is a source of voltage with a constant potential difference. Then you will construct a circuit with 2 bulbs. We have 2 different ways to realize this circuit. And finally, we'll be using the 3 bulbs. So in the first part, please make sure, we need to make sure that the voltage does not exceed 3 volts. The power supply is directly connected to the bulb. So it's a simple circuit with 1 bulb directly connected to a battery, to a power supply. Okay, this will be our, let's say, reference circuit. We'll compare the other circuits to this one. You'll be able to draw the circuit diagram with a battery and the right symbol of a light. You can find all these symbols in your lab manual. Then we need to prepare a circuit with 2 bulbs. If we have 2 bulbs, we have 2 different ways to prepare a circuit. Either a circuit with 2 bulbs in series or 2 bulbs in parallel. And you need to compare the brightness of these bulbs to the first circuit, to the circuit with 1 bulb. If you want to draw the ways to prepare a circuit with 2 bulbs, if we have 2 bulbs in series or 2 bulbs in parallel, these bulbs should be connected to the power supply. So we will design these two circuits on the electrical board circuit, and then you will compare the brightness based on your observation and based on the formula relating the power to the current and the voltage or the resistance of a bulb. So to prepare these circuits, we need to use these lead wires. So if you want to prepare a parallel circuit, these 2 bulbs are connected in parallel. Now we connect the power supply and we turn on the Okay, you need to compare the brightness of this circuit, of the bulbs in this circuit, to the circuit number 1. Then we'll turn off the power supply and we'll prepare the series circuit. So these two bulbs are connected in series. We need an input and an output of the circuit. We turn the power supply on and we watch the brightness of these bulbs. And you need to think about if we unscrew one bulb in circuit number 1, so in the circuit in series or in the circuit in parallel. So what will happen if we unscrew one bulb? In part 3, we'll be using 3 bulbs. Okay, in the first question, we need to connect these 2 bulbs in 2 different ways. We need to obtain the same brightness. So we'll be doing the same procedure. The power supply should be connected to 3 bulbs in series. These 3 bars are similar. They have the same resistance, so they should shine with the same brightness. The second circuit is a parallel circuit. Also here we will obtain the same brightness. The difference is between the 2 circuits, not between the bulbs in the same circuit. So the first circuit is a series circuit. So bulb A is connected to bulb B. Bulb B to bulb C. And we need an input and output of the circuit. We turn the power supply on. So we need to watch the brightness of these 3 bulbs in series with the same resistance, identical bulbs. Now you need to draw the circuit diagram of these 3 bulbs and to explain why we have such a brightness. Now we'll disconnect the circuit and we'll prepare the parallel circuit. So these 3 bulbs are connected in parallel. Turn on the power supply. Okay. So also here we need to watch the brightness to explain our observation and to use the relationship between the power, the current, the voltage, the resistance to explain what's happening. And also you need to answer the question regarding the part of if we unscrew one bulb, what will happen in circuit number 1, so in series and in parallel. And you need to compare the brightness of these bulbs to the brightness of the simple circuit, so the circuit with 1 bulb. Now we need to think about a circuit with 3 bulbs, where 2 bulbs shine with the same brightness and the third one with a different brightness. We have 2 different ways to prepare this circuit. So if we put bulb A and bulb B in series, and these 2 bulbs will be in parallel with bulb C. So as you know, if you have a series circuit, you have the same current. If you have a parallel circuit, you have the same voltage. So based on the current and the voltage, you will prepare this circuit. The other circuit will be bulb A and bulb B in parallel, series with bulb C. Okay, so we'll prepare one of these two circuits. You will explain how the bulb behave. You will do the calculations without values of the power, the intensity, and of the voltage based on the resistance of these bulbs. And keep in mind that we have they have the similar resistance. So we have a same R. Now we'll prepare this circuit, and also you need to think what will happen if we unscrew one bulb in each case. So let's say that we will prepare the circuit bulb A and B in series parallel with bulb C. So this is bulb A, B and C. So A and B in series parallel to bulb C. And now we'll connect the power supply. Okay, you can see bulb C is brighter than bulb A and bulb B. Bulb A and bulb B, they have the same brightness. So you will be able to explain why bulb A and bulb B, they have the same brightness, why bulb C is brighter. And if we unscrew bulb A, what will happen? If we unscrew bulb B, what will happen? If we unscrew bulb C, what will happen? Finally, after finishing working with bulbs, we'll prepare a circuit with one bulb and a potentiometer. A potentiometer, it's a resistor, it's a variable resistor with 3 terminals. If you look here, we have 3 terminals. The terminal in the middle is the one connected to the adjustable wire inside the resistor. So if we turn the resistor to the right or to the left, we'll be increasing or decreasing the value of the resistance. And using Ohm's second law, you will explain what will happen if we increase R or if we decrease R. So V equals Ri. If we increase R, what will happen to the voltage, to the current in the circuit? So in this circuit, we'll simply connect a bulb to the potentiometer, to the rheostat, and they will be directly connected to the power supply. So we have a bulb connected in series to the rheostat. They are connected to the power supply. So we will use 2 terminals. We need to use the one in the middle because we need to change the value of R. So C is connected to the potentiometer. So here we have a simple series circuit where the bulb is connected to the potentiometer. We turn the power supply on, and if we turn the wheel of the potentiometer to the right or to the left, okay, the brightness of the bulb will decrease. So if the brightness of the bulb is decreasing, what is happening inside the circuit? So I is increasing or decreasing, R is increasing or decreasing. Keep in mind that we have the same potential difference. So we're applying a voltage around 3 volts. Okay, so we're changing R. If we change R in a circuit, what will happen to V or to I in the circuit? So you need to check the report to answer the question. This report, we don't have any values in this report. It's an observation lab. That's all.